There is a patch of flat, featureless ground in the South Australian Outback, about 550 kilometres north-northwest of Adelaide, where the landscape gives nothing away. No ridgelines worth mentioning, no visible mineralisation at the surface, no colour in the soil to catch your eye, just red dirt, dry scrub. And the kind of silence that makes you feel like nothing of consequence has ever happened here. But beneath that surface, buried under hundreds of meters of ancient sedimentary rock with no hint visible from above, sits the richest copper resource ever found on this continent. A deposit so large that geologists created an entirely new category of ore deposit just to describe it. A find that, when it was first drilled in 1975, nobody outside a small team of exploration geologists in Western Mining Corporation believed was real. This is Olympic Dam. And what lies beneath the South Australian Outback here is one of the most extraordinary concentrations of metals anywhere on Earth. The deposit sits under the Roxby Downs Pastoral Station on the Stuart Shelf, a geological province defined by the flat-lying sedimentary rocks that blanket the eastern margin of the Gawler Craton. The Gawler Craton is one of the oldest and most stable fragments of continental crust in Australia, a Precambrian shield that formed roughly 1.5 billion to 3 billion years ago. It is the kind of ancient, rigid geological terrain where you would not typically expect to find a giant ore deposit close to the surface, and that is precisely why Olympic Dam remained hidden for so long. There is no surface expression whatsoever, no gossan, no staining, no outcrop. The mineralized rock begins hundreds of meters below the ground, sealed beneath a blanket of flat-lying sediments that accumulated over the deposit long after the ore itself had formed. To understand what Olympic Dam actually is and why it matters, you have to go back roughly 1.6 billion years to a period of intense volcanic and tectonic activity on the Gawler Craton. At that time, the crust in this part of Australia was experiencing a major thermal event, a period of large-scale magmatism in which enormous volumes of molten rock intruded into the crust and erupted at the surface. One of those intrusions is now known as the Roxby Downs Granite, a large body of rock that solidified from magma deep in the crust. It is within and around this granite that Olympic Dam's mineralization formed. The deposit is hosted in what geologists call a hydrothermal breccia complex. Breccia in geology is a rock made up of angular fragments cemented together, the result of intense fracturing and shattering of existing rock. At Olympic Dam, the Roxby Downs granite was fractured and broken apart on a massive scale. And then those broken zones were flooded with hot metal-rich fluids that had circulated through the crust. Those fluids, driven by the heat of the magmatic event, carried dissolved copper, gold, uranium, silver, and iron. As they moved through the fractured granite and cooled, the metals precipitated out of solution and were deposited within the breccia zones. The result was a mineralized system extending over more than 20 square kilometers laterally and several hundred meters vertically, a vast, irregularly shaped body of broken rock saturated with copper sulfide minerals, uranium oxide, gold, and silver, all held together in an iron oxide-rich matrix that gives the ore its characteristic red and purple colors. Geologists now classify Olympic Dam as the world's first recognized iron oxide copper-gold deposit, known in the industry by the acronym IOC. When the deposit was identified in the 1970s, nothing quite like it had been described before. It did not fit the existing templates for copper or uranium mineralization. It required a new geological model to explain how copper, uranium, gold, and silver had all concentrated together in such extraordinary quantities in a single system. And once the model was established, geologists began recognizing IOG deposits at other locations around the world, but none of them came close to the scale of the original. The discovery itself is a story of scientific intuition backed by institutional patience. In the early 1970s, a geologist at Western Mining Corporation named Douglas Haynes developed a new conceptual model for copper mineralization. He proposed that oxidized iron-rich fluid circulating through the crust could carry copper upward along fault systems and concentrate it in domed structural traps. It was an unconventional idea, and the terrains he identified as prospective did not look like typical copper country. But WMC backed the theory and committed to exploration. By 1974, a geophysicist named Hugh Rutter was working through gravity and magnetic data across the Stuart Shelf in South Australia. He identified a subtle geophysical anomaly near Roxby Downs. a slight variation in the Earth's gravitational and magnetic fields detectable only through careful analysis of survey data invisible from the surface. Haynes identified it as the kind of target his model predicted. In July 1975, Western Mining Corporation drilled the first hole, designated RD1, at 353 meters below the surface. The drill intersected 38 meters of rock grading 1.05% copper along with uranium, gold, and silver. It proved the model worked, and after further drilling extended and defined the resource, the scale of what had been found became clear. By the late 1970s, WNT had outlined a resource exceeding 2 billion tons, grading 1.6% copper, with significant uranium, gold, and silver throughout. That number still represents one of the largest copper resources ever outlined in a single deposit anywhere on Earth. The deposit contains 4 distinct commodity streams: copper, uranium, gold, and silver, all occurring together within the same mineralized system. No other deposit of comparable scale offers that combination. The sheer size of what was found beneath Roxby Downs is a number that is difficult to hold in your head. 10.4 billion tons of total resource. That is the current figure, not reserves, total mineralized material in the ground. Even at an average copper grade that varies through the deposit, the contained copper in that resource represents a quantity of metal that would take the current operation centuries to fully extract at present production rates. And that is without accounting for the uranium, which Olympic Dam hosts in the single largest known uranium deposit on Earth, or the gold and silver present throughout the ore body. If that didn't register, 10.4 billion tons of mineralized resource containing the world's largest uranium deposit, one of the largest copper accumulations on the planet, and significant gold and silver, all sitting beneath a featureless patch of South Australian outback that most Australians will never see. Then, you're exactly the kind of person this channel exists for. People who find it unsatisfying that something this extraordinary exists and nobody talks about it. If that's you, you already know what the subscribe button is for. The mine that was eventually built here opened in 1988, 13 years after the discovery. Getting from a geophysical anomaly in the Stuart Shelf to a producing underground mine required not just the physical work of sinking shafts and building infrastructure in the remote outback, but also the creation of entirely new legislation. The South Australian government passed the Roxby Downs Indenture Act in 1982 specifically to provide a legal and regulatory framework for the development. A bespoke mining law that covered royalties, approvals, and the conditions under which the deposit could be developed. That legislative step alone tells you something about the scale of what was being built. You don't pass dedicated acts of parliament for ordinary mining projects. Today, Olympic Dam is an underground operation reaching more than 860 meters below the surface. More than 470 kilometers of tunnels have been developed underground, a network of drives, declines, ore passes, and excavations that forms a city beneath the desert. The ore is hoisted to surface and processed through an integrated metallurgical facility on site that is unique in the global copper industry. The entire chain from mined ore to finished copper cathode. Uranium oxide, gold, and silver is completed at Olympic Dam without the ore being shipped elsewhere for processing. That integration gives the operation a degree of cost and quality control that very few mines anywhere in the world can replicate. Current production sits at around 316,000 tons of copper per year. That figure alone makes Olympic Dam the largest copper mine in Australia by a significant margin and places it among the top copper producers globally. But the number that matters more for the long-term story of this deposit is not production today, it is what the resource represents for the future. BHP, which acquired Olympic Dam through its takeover of WMC Resources in 2005 for 9.2 billion Australian dollars, is investing more than $840 million in current underground development programs. A new access decline into the southern mine area alone is expected to unlock additional vertical capacity and extend the operating envelope of the mine. Exploration is continuing at depth, with drilling indicating mineralisation extending beyond 1 kilometre below the surface, and the bottom of the ore body has not yet been definitively identified. What makes Olympic Dam particularly significant in the context of the energy transition is the nature of the metals it produces. Copper is the single most important metal for electrification. Every electric vehicle requires roughly 4 times the copper of a conventional vehicle. Every wind turbine, every solar installation, every grid-scale battery system, every power transmission line that carries renewable energy from generation point to consumer, all of it is built on copper. Global copper demand is projected to grow by around 70% by 2050 as the world electrifies its economies. And the world's largest single copper resource sits beneath a livestock station in the South Australian Outback, already producing and with the geological depth to keep producing for well over a century at current rates. The deposit was not found because someone kicked a rock and saw metal. It was found because a geologist built a theoretical model for how a particular type of mineralisation should look in the subsurface. A geophysicist identified a faint anomaly in gravity and magnetic data that matched that model, and a company was willing to drill into featureless ground on the basis of an idea that most of the industry had not yet accepted. The discovery required all three: the theory, the data, and the willingness to back both with an exploration drill. That is a chain of events that, had any single link been missing, leaves the richest copper deposit in Australian history undiscovered indefinitely beneath the Roxby Downs station. It lies there with no surface expression, sealed by ancient sediment, in a part of the country where nothing about the landscape suggests what lies below. The ore body did not announce itself, it waited to be found by someone who knew what to look for and was willing to look. And in a world that is increasingly going to need copper, enormous quantities of it, delivered reliably from large, long-lived deposits. That quiet patch of South Australian outback turns out to be one of the most important pieces of ground on the planet. I hope this gave you something you genuinely didn't have before. The most extraordinary things are often the least visible. If this is how you want to spend your time, you already know what to do. And a genuine thank you to everyone supporting this channel through Patreon and YouTube memberships. It is what makes this possible.